This time, I'm going to talk about how to rectify heteroskedasticity in Python. About 1 year ago, I took another video talking about how to test heteroskedasticity in Python. If you haven't watched that video, you are welcome to watch that video first. One of my viewers asked a question. Now, we tested heteroskedasticity, and how can we rectify it? First, let's review what heteroskedasticity is. When you build your model, you have your independent variable and you have your dependent variable. And of course, with the real sample data, you will have standard error of those variables. If all those standard error remain constant, that means it's scattered around the average value evenly. We call it homoskedasticity. But if the standard errors are dependent on the independent variables, we call it heteroskedasticity. Now, let's review what are not consequences of heteroskedasticity. Heteroskedasticity does not cause bias in the coefficient estimates. And R² is not affected by heteroskedasticity. And our estimate of root mean squared error is valid, even though when you have heteroskedasticity. Then, what are consequences of heteroskedasticity? OLS model is no longer best linear unbiased estimator. And we no longer have the best estimator because error variance is biased. We have incorrect standard errors, invalid t statistics, and f statistics. And RM test is no longer valid. How can we check heteroskedasticity? We can use QQ plots and check heteroskedasticity visually, or we can use Breusch-Pagan test, or we can use wet tests. In my previous video, I discussed how to test heteroskedasticity in details. You are welcome to watch that video first if you haven't done so. Then how can we rectify heteroskedasticity? We can rebuild the model with new predictors, or we can use Box-Cox transformation. That means we can use Box-Cox transformation to transform the variable to make it approximate to a normal distribution. Let's check the formula of this transformation. We can transform variable y to a new y depends on lambda with this formula. When lambda equal to 0, we will take log of y. And when lambda is not 0, we will use this formula to transform it. Box-Cox transformation only cares about computing the value of lambda, which varies from -5 to +5. So we only have one parameter, lambda, in the transformation. Then it will transform non-normal curve to a normal curve. Let's take a look how can we implement that in Python. In Python, the transformation is quite straightforward. First, we will load the library, and then I will generate some dummy data with this exponential function. So if we draw the generated variables, you can see it's not normal distribution. And then we will call this BoxCox library to transform this original data to the new data. After the transformation, you can see the new variable looks very close to a normal distribution. This is original data. This is the data after the transformation. As I mentioned in my slide, there is a one parameter we use in this BoxCox transformation. That is lambda. And in this example, the lambda value we used is 0.265. So after this BoxCox transformation, we transform a non-normal distribution to a normal distribution. This is how we can rectify heteroskedasticity in Python. Please provide your comments and subscribe to my channel. Thank you for watching.